Hotline, what is your emergency?
All right, hello everyone. Welcome to our live homework hotline show.
Yeah, welcome. We're all here to answer your math and science questions.
And we're not just here to give you the answer, but we are here to help you with each step of the problem so that you actually understand how to do it.
Yeah, I'll be able to work with you through your math problems. My name is Nathan, and I teach at Emily Griffith High School.
And I can help you with your science problems. My name is Sam, and I'm a science teacher at the Contemporary Learning Academy.
Like Nate, I can work with you on math problems as well, and I also teach at Emily Griffith High School. On Wednesdays, Sam shows us some awesome science experiments. And Sam, tell us about what we're going to do today.
I'm just going to say that it's going to be a little bit cheesy. So you'll need to stick around, stay tuned to find out what the experiment is.
I feel like that's a pretty good clue there. We're here every Tuesday and Wednesday from 4:30 to 5:30 p.m. Call us at 720-424-1666. We love getting your calls because we can walk you through the problems a little bit more in depth and answer your questions as you have them. And if you don't understand something, we can clarify. Becca, how can our viewers watch?
Well, you can watch our shows in several different ways. For live broadcasts, you can watch us on Comcast, Channel 22, Prism TV, Channel 8007, livestream.com/DPS TV 22, Facebook Live, or YouTube Live as well, which is not what you're seeing on your screen, but we do have a graphic to show you where you can find us. There it is. Okay, so these are all of the different places I just mentioned. If you'd like to see some of our past clips, you can watch us on YouTube by searching for Denver DPS TV Homework Hotline. So those are all of the different ways that you can watch us. You got a lot of options there. Facebook Live is new this year, which is probably, I don't know, the easiest way.
Mm-hmm. Yeah, and the Homework Hotline is sponsored by the Contemporary Learning Academy and Emily Griffith High School. And today we actually have one of our Emily Griffith students with us, Tori. Why don't you tell us a little bit about yourself and what you're going to be doing here on the show?
Okay. Hi, I'm Tori, and I go to Emily Griffith High School. And I'm here to read the trivia question in the beginning of the show and answer and read through your guys' comments throughout the show and give them to Nate, Sam, and Becca.
All right, so what's the trivia question for today?
Would you guys like to start off with math or science?
No, the trivia question.
Oh, trivia question. Okay. Today's trivia question is, where would you find the world's most ancient forest?
I don't know.
It's a good question.
I go with no idea on my end.
No idea. Well, if you have an answer to the question or think you might have an answer, just guess. You can guess. You could do that. Give us a call or contact us in some way by the time the show ends at 5:30. I'd like to give you the ways to get in contact with us. You might have seen it on your screen earlier, but let's go through those one more time. You can call us, and as Nathan mentioned earlier, that's probably the best way to get a hold of us. The number 720-424-1666. That'll be on the top of the screen throughout the show. But you can also send in questions via social media on Facebook or Twitter at EG Homework. You can text us your questions at 970-680-3771, or you can also email those questions to us at homework@emilygriffith.edu. So let us know if you've got questions, and also let us know if you have an answer to that trivia question that Tori told us earlier. All right, well, I guess let's jump back to Tori and see if there are any questions on social media. Do we have anything waiting for us?
Let's go to Facebook. Okay. No, go back down. And then we're going to go to users posts. Okay. Okay. Yeah,
Looks
okay.
like those might be the ones from last season, but I think on the Gmail we might have a few new ones.
Okay.
Yeah, I think we
Let's
do.
Go to Gmail then. Okay.
I would be happy to do that science question from
Okay.
Louise Becker if you want.
Okay, so we have a science question from Rebecca. And she says, "Hi guys, I have a chemistry question for you. I need help balancing this equation. And the equation is Fe plus H2O.
Oh,
And
What do you
then
need mirror?
a little
I'm gonna need one
arrow.
of you guys in a second.
Then it converts to Fe3O4 plus
I'll get this.
H2.
Awesome. So we're balancing an equation. So another way to say the equation, it looks like, is it's iron plus water yields iron oxide and hydrogen gas. So I'm going to have, is Nate doing it for me?
Yeah, I'm
gonna
writing
have
this down.
to.
If I remember right, I should leave a little space for you at the
Oh,
front. of
Nate,
these,
you were
right?
so good. So Nate's going to leave a little
Yeah.
space in front of each of the chemical symbols, and we will balance it with him. So there he is. And again, I think one thing that stumps us sometimes with chemistry is there's more than one way to say this, right? Cheers just said it perfectly. Fe plus H2O, arrow, Fe3O4 plus H2. But we can also say it in plainer English, which is just Fe is iron. So iron plus H2O water yields, usually we read that arrow as yields. Iron oxide is that chemical right there. And then hydrogen gas is the last one. So when we're balancing equations, the goal is we want to make sure that we can figure out exactly how much of each kind of chemical is going to be created. And because we know that matter cannot be created or destroyed, something that we really harp on in chemistry class, whatever number of atoms of every chemical that we have on the left side of our equation should correspond to the number of atoms of those types we have on the right side of the equation, on the product side of our equation. So this is how I would solve this. So the first thing that I would do is I would look at it and I would say, okay, so I noticed that on the left side of my equation I have 1 iron, or just iron by itself, and on the right side I have 3 iron. So I'm probably going to end up needing 3 iron. So I'll go ahead and put a 3 in front of the Fe on the left side.
Just a big 3 right there, right?
Big old 3.
All right.
So what Nate just put in is what we call a coefficient. In Nate and Becca's class, they use coefficient all the time, probably, likely.
Yep.
Every day.
In science, we use it a little bit less. Sometimes we use it to refer to parts of a particular equation. But in chemistry, we talk about balancing coefficients, and they're these numbers. So Nate's going to put them in red for us. So again, we've got 1 iron on the left originally, but we just put a 3 in front of it. So now we have 3 iron molecules on the left, which corresponds to, on the other side, we've got Fe3, 3 iron molecules right there. So we're even in terms of iron. So the next thing I'm looking at is my hydrogen it's in balance. I have H2O on the left and H2 on the right. Even though on the left the H2 is combined with oxygen, there's still 2 on the left and 2 on the right. So those are cool for now. But I also noticed that there's only 1 oxygen on the left and there's 4 on the right. So to compensate for that, I'm going to have Nate put a 4 in front of my H2O.
So that's going to throw off. Now we have too many hydrogens, right?
And now our hydrogens have been thrown off, right? So originally our hydrogens were in balance, but since we have 4 waters now, 4 H2Os, I have to multiply that coefficient by whatever, or multiply any of the chemicals there by the coefficient. So since there's 2 hydrogens in H2O, and I have 4 molecules of H2O, that means I have a total of 8 hydrogens. Over on the other side, I already have 2 hydrogens on the product side. I'm going to have Nate put a coefficient of 4 in front of that H2, balancing us out. So now I have 3 iron plus 4 water yields, and I'm going to have Nate put a 1 there in front of my iron oxide. One mole of iron oxide and 4 moles of hydrogen gas. So I went through that kind of quickly in a sort of simple way where I looked at the left and I looked at the right to try to determine what do I need to add to each side to make sure that the sides are balanced. At some point here, I'm going to have to I'll have to think about a more complex balancing question because there's a way to solve it through a system of equation. And I think that typically when we get into higher level chemistry, we need to use systems of equations to balance these. So I'll bring in a more complicated one someday and have you guys help me out with that.
Okay.
That's interesting because I was actually wondering about that.
Yeah.
Like,
Right.
It seems like a lot of this is just kind of plugging stuff in, hoping
Playing
it works
with
out.
it.
If it doesn't, then making some adjustments.
And I think
Yeah,
that really that's the
and playing
fastest way
with
to
it.
do this type of a problem that we just looked at. So a problem that is so simple and that has just very few chemicals like that. But if you have a really complex chemical being combined with another complex chemical and yielding 2 or 3 other complex chemicals, it may really behoove you to look at it from a systems of equations standpoint. So again, I'll bring in an example of that in one of these weeks coming up.
Can I ask
I
you
would
one
like
other
to see
question?
that.
So you
Sure.
put a 1 in front of the iron oxide?
Iron oxide?
Now, a lot of times in math when we have coefficients of 1, we just don't put them there. Are you
Nice.
putting it there just to be clear that there is a 1 there? Or if you
absolutely.
were doing this, would you always write that?
No, so I mean, let's be clear. If you're a chemist working in a real field, maybe you work for city water, and you're testing chemicals in the water, you may run equations, but you're probably not adhering to some sort of really strict
Right.
standard. Normally, you probably wouldn't put a 1 there.
Okay.
But as a chemistry teacher and somebody that's always thinking from the perspective of, I want my students to lay out exactly what they know, to me, a blank there could indicate that they're not exactly sure. So I always
Right.
require that they put the 1.
Okay.
That makes sense.
Yeah.
It does make sense.
So, cool.
All right. Well, we have somebody who thinks they know the answer to the trivia question.
Oh, no way.
Oh.
Yeah. So let's repeat the trivia question one more time, just so our audience knows what we're answering. And then also, before we do that, I want to make sure we have that person on the line. So, Tori, go ahead.
Okay.
Read our question.
The question is, where would you find the world's most ancient forest?
All right. Hello. Are you there?
Yes, I'm here.
Hi. Do you have a guess for our trivia question?
Yeah, I Googled the answer, so I'm not, betting any money or anything on it, but it says here, New York.
New York. The most ancient forest is in New York. Is that our answer, Tori?
No.
Oh, that's not our answer. So
Oh,
Google, man.
What did
Yeah,
Google tell
slipping.
you? What did Google say?
City Park or the Central
It
Park?
says the floor of the world's oldest forest was dug up in New York.
Huh.
So that's what it says. So
Oh, did you say dug up in New York?
yeah, so it's more like an archaeological type
Oh.
of thing than like currently. So
Okay.
This may be remains of the most
Yeah.
ancient forest
yeah.
ever known. So that
Yeah,
could be.
it got a little deeper than
it could.
I
Yeah.
anticipated.
So I think we maybe should have clarified. We were looking for the oldest living forest, continuously living
Okay.
forest on the earth.
And we should have clarified,
And,
huh?
and
Yeah.
you're not the only. So at the beginning of the show or before the show, I was actually trying to Google the answer and I came up with some stuff that's maybe not the answer that we have. So we'll have a discussion about this later. But
Yeah.
thank you for calling one in.
Thank you.
Thanks.
Yeah. Hey, watch us next week. Try again next week, too.
I didn't know making rust was so complicated.
It is. It is. It seems
Yeah.
simple, and it's just water and iron, but there's a lot going on.
All
right.
Thanks, guys.
All right.
you.
Thank you for calling.
All right, thanks.
Thanks. All right. Well,
It's a contentious trivia question, I think.
It is.
It
So
is. I
to-
wouldn't have thought it was so debatable.
Right. Well, and so to be more clear, I guess what we really are asking is, where would you find the world's most ancient living forest?
And we're saying continuous living forest as in forest as like a thing, not a forest with the oldest trees in the world.
Yeah,
which
that's
is another distinction
what
that should be
confused
made.
me. That was my thought was, oh, where are the oldest trees? But that's not necessarily it. It's continuous forest.
So if a forest is sort of an ecosystem of trees, right? This is a continuously living forest on
Yes.
the earth. So
Yes. Well, so you
Google-
can still
Google
call
that.
in. You can still call in. There has not been a winner yet, and we do have prizes, by the way, and they are pretty cool. What are our prizes again? They're symphony tickets.
Colorado Symphony tickets.
Yes.
I
Oh,
believe
that's
you
such
can
a good
choose
prize.
which symphony you go to.
Ooh.
That's cool.
So
they played with the vodka last year.
Did they?
They
I
did.
love the
I
vodka.
heard that. I didn't get to go, but
I listened to some of it on CPR, but it sounded really good.
so that's an opportunity that you have. So you should just see if Google can help you with with answering the trivia question. All right, well, let's go get some more questions answered. Let's go back to Tori at the social media board. Tori, do you have anything?
Oh, okay.
Yeah, and we'll look for a math question
Yeah,
this
let's
time.
look for one of
Question
those.
for you guys. Oh, come on. It's like this thing knows it's on camera, so it decides to mess up. Okay. Okay. Just go down. And there doesn't seem to be anything
There
new
were.
on
Can
here.
you scroll up, Tears? I think there might be some from Jacob Hill right at the top. Above these ads. Okay, do you see those from Jacob
Oh,
Hill?
okay,
I
yeah.
think those are a few math questions
Okay.
these guys can do.
So on Twitter, we have a question from Jacob Hill, and he says the population of a country increased by an average of 2% per year from 2000 to 2013. Oh yeah,
Oh, I guess it continues on the one above.
yeah. If the population of this country was 2 million people on December 31st, 2013, then what would the population of this country be on January 1st, 2000 to the nearest 1,000?
I'm going to need those numbers again. I can't see them at all. Are you able to see them?
Yeah, let me see if I can pull them up.
I've got it right here too. So we're going from the year 2000 to 2003. Is the
Am I
range?
doing this one or are you doing this one, Nathan?
You can go either way. You already got it started, so.
Not much. You go for it. It's
All right.
yours.
All right, Nate.
What do we got?
Years
Passing
2000
it off.
2003,
So from 2000 to 2003.
and at the end of 2003, so December 31st of 2003,
Okay.
the population is 2 million.
So we're talking about the beginning of 2000?
Yeah, the beginning of January 1st, 2000
Okay, to the
to,
end
to
of
December
20,
31st, 2003. 2 million people on December 31st, 2003.
Okay. 2 million.
And over this period, the population of the country increased by an average of 2% per year. So the question is, to the nearest 1,000, can you give us the population on January
Oh.
1st, 2000?
So this is an exponential question. So what we need to first talk about is the form of an exponential equation. So I typically write it as y equals a times b to the power of x. And talking about what these components mean really helps. So if you feel like you're just sometimes lost in these exponential, I would always think about what these components mean. So y, think about y as like your final amount, in which case a is going to be your starting amount, like your initial. So in this case, my first thought is I know my final amount. I know that at the end of 2003, there were 2 million people, right? It's population. And then we need to think about the growth rate, B here.
And Nate, can I just make a note on that?
Sure.
I think it increased by 2%. Just
Oh, not
2%.
2.3, okay.
Yeah, sorry, I think I might have
Oh.
mumbled that.
Yeah, I
How
was
did
like,
I
wow,
write-
this is a really specific question.
Yeah, no,
I-
2%. 2% per year.
Okay.
I somehow wrote down or heard 2.3 for some reason.
Yeah.
That must have been me.
Okay, so let's change that to 2%. And then this is going to be your growth rate. Let me do that in the different colors. It's not confusing. Growth rate. And then this x up here is going to be time. So we can think about this a couple ways. One is I don't really like, and Becca, maybe you can chime in if this is something you do or not. When I have these really big numbers, like 2 million, like a nice, even, really big number, I usually just go with 2. Is that something you do, or do you just go 2 million?
I usually do too.
Okay.
Yeah.
So in the end, we're going to say, I'm going to convert this to 2 million, because as you're working through these math problems, sometimes we have these really ugly, like big numbers that make it challenging on a calculator even. So I like to just make an easier number to work with.
And we know that whatever our solution is or whatever our answer is going to be in millions.
In millions,
Just
yeah.
like we're reporting this to. We're saying it's
Right.
2 million.
Right.
You know, million is almost the label now.
Yeah. So when we get our final answer, we're probably I'm gonna guess we're gonna have some crazy decimal, and we're gonna end up just multiplying it by 1 million, or saying whatever million. So all I'm gonna do now is think about like this equation that I have here, and I'm gonna say, well, do I know the final amount? And actually, let me take a step back really quick. Again, I like to read these problems and really think about what's being asked. And we're really trying to figure out how many people were there in the beginning of 2000. So I'm looking for this initial amount, which means if this is what I'm looking for, I have to know every other component of this. So I'm going to walk through this now and think about like what information I have. Do I know the final amount? Yeah, I know at the end of 2003, we had 2 million people. So I'm going to write this over here, and I'm going to say 2 equals A. I don't know what the A is, because that's what we're looking for. And now B is a growth rate, and this is kind of a tricky, I don't want to just say it's 1.02, but think about like if something grows by 2%, if you want to figure out what percentage it grew or the amount that it was increased by, you would just do that number times 0.02. You'd convert it to a decimal. But we also have to consider that we still have our initial amount. So it's going to be 1 plus that. And I'm not going to get too into that. I'm going to assume that that's something that you know, because that'll take an extra 5 minutes. So we're going to do times 1.02 to the power of x. And this one, I think they did this on purpose, a little tricky.
Well, it's not
Beginning of 2000.
Oh, I see what you're saying. I see what you're saying.
So,
Sorry.
Yeah, I'm looking for x right now. I'm thinking about what it is. Beginning of 2000 to the end of 2003, my first thought might be, oh, it's 3 years, right? Mm-hmm. But we said the beginning of 2000, so we have all of 2000 is 1 year. We have all of 2001 is 2 years. Mm-hmm. All of 2002, we have all of 2003. So we're actually talking about 4 years. So I'm going to put a 4 up here. So you got to be really careful about that because we said beginning of January to end of December and just think that through. Mm-hmm. Now, from here, we're just going to solve. And so, Becca, if you could help me out with the calculator. So 2 equals, and all I'm doing is simplifying this side of the equation. We don't really like to have exponents when we don't have to have them in this case. So Becca did this on the calculator. 1.02 to the power of 4 right here is going to be this kind of big number here, 1.082432216. Now we have basically a simple equation to solve. 2 equals a times some number, so we're going to divide it by that number. And I want to kind of point out one thing here is that I don't want to keep rewriting this entire thing, but in a calculator you'll see, you probably can't see this, but it's kind of a long number, and you don't want to like leave stuff out if you want to be more precise. So we end up just doing the answer. So, but I am going to divide it by this on both sides. I probably should have just rounded it. And we're going to get a equals, let's see, 2 divided by that answer, 1.847.
Yeah, use that answer button in your calculator to do the calculations because it helps you keep it accurate, as Nathan was saying. Don't round it if you don't have to. Use that answer button.
Yeah. So we have 1.8476908, and that number continues a little bit further. But remember, we wanted to know how many people to the nearest, what, thousands?
Millions.
Nearest thousand.
Nearest thousand.
Nearest thousand.
Was what we wanted the answer.
So what I'm going to do with this number is I'm just going to multiply this by 1 million. And I get, and I'll write this down so it's clear. I multiplied this number by 1 million in my calculator. And you're going to get A equals 1,847,690. And we wanted to round it to the nearest thousands. So we can actually round it to 1,848,000 people approximately. So these problems can seem a little tricky, but if you just try to think about what you know and really like don't just try to memorize this equation and plug stuff in. Think about what all of it means and how it relates to each other. That'll help you kind of think about like what information you have and what information you're looking for and solving from there.
And I think also one of the confusing parts about these types of problems is what kind of equation do I write?
Right.
You know, and if you can understand that, oh, well, when something's growing by 1%, or decreasing by 1%, that's always an exponential relationship. Then you then know what kind of equation you have and fill in our parts.
Right.
So thinking about the relationship between the numbers as well. All right, so, we had another guest for the trivia question, but they're gone. So if it was you, call back, because you could be winning a prize today.
Sorry I took so long. I may have cost you Colorado Symphony tickets.
They'll call back if they really want them. They will. They'll call back if they really want them, I think.
Yeah.
And they did.
Yeah.
So they're here. Hello? Hello?
Hello.
Hi. Thanks for calling Homework Hotline. Do you have an answer for the trivia question?
I believe I do.
Okay, what do you think it is?
Would it happen to be the Black Forest in Germany?
Tori, is it the Black Forest in Germany?
Oh.
Not according to the
Not the
information
Black
we have.
Forest in Germany.
Did you get an age? Did you get an age on the Black Forest in Germany
How old
when you
was
looked
it?
it up?
I did not, actually.
Okay, so we have a different answer, and when we talk about it, we'll talk about the actual age that it is. But do a little more digging and see if you can get a specific number of years old that it's supposed to be.
All right.
Okay. And what's your name?
Jacob?
Jacob? I thought so. I thought that was you. I really
thought
did think
so,
it was
too.
you. I was like, I recognize that voice. Okay, call back if you think that you can find it. Okay, Jacob?
All right, will do.
All right, thank you for calling.
Yep.
All right.
Now, this is almost as confusing as what are the 7 names of Niagara Falls, or whatever the question was from
There's
yesterday,
3
right?
names.
Yeah.
Were there really?
7.
But then there were actually 5 or something, I think.
But they were all names of different falls, not
They were just a part of
Niagara Falls.
Right,
Yeah.
what are the Niagara
Yeah.
Falls, right? I
It's
see.
a very
Trivia questions are
contentious
tricky.
season of Homework Hotline.
All right. Well, we're going to take a little break. We're going to look at some stuff from Emily Griffith Technical College, and when we come back, we're going to do our science experiment with Sam. I'm so excited. All right, see you soon.
Hey girls, good to see you.
This is Carlos, a graduating senior
How are you?
here at Emily Griffith High School.
I came from North High School, Westminster High School, and Jefferson High School.
As a group, get that jotted down on
Like many teenagers, he had, well, a hard time showing up to school.
I didn't show up because of the surroundings, the people that were there. Bad influences or just bad decisions. The 2 circles.
Oh.
Carlos had an option.
My cousin actually came here and graduated from here, and I took the opportunity and jumped on it to come to Emily Griffith High School.
Okay, which one was this?
Listen to his teacher, Haley Todd.
He came to Emily Griffith with 1 course completed, 5 credits, 1 course.
But at Emily Griffith High School,
We're able to tailor to our individual students. We have really small class sizes. We have a smaller school community. We're able to build relationships with the students so they're connected and they have meaning and purpose when they're here. I think all of these things contribute really heavily to a lot of success that we see. Carlos is one example of that.
The type of student I am now compared to how I was before is I'm a student who works hard. I have persistence in what I do. I don't give up on anything that I do, whereas before I used to give up easily and I never came to school. Well, I came in to Emily Griffith High School with 5 credits, and in a period of 2 years I made up all of my credits. So 4 years of high school I basically made up in 2 years.
One other exciting fact about Carlos is that all of the teachers get to vote each year before our graduation ceremony and recognized 1 student as our outstanding student of the class of 2015, and it was close to unanimous that Carlos was absolutely deserving of this award.
but that's not all. Carlos is also graduating with a certificate in water quality management from Emily Griffith Technical College through concurrent enrollment.
The way I actually heard of Emily Griffith concurrent enrollment program was through my counselor. I was doing fairly well my first few months of it at Emily Griffith. Perfect attendance, and she mentioned it to me. And I decided that I wanted to do water quality management.
I strongly encourage concurrent enrollment. I think it's invaluable, the opportunity to attempt a new post-secondary program or to explore a new potential career path while you're still working with others who are supporting you on your diploma and who you have someone to process with if you run into a challenge.
What Emily Griffith High School did for me was turn my life around, making me into a success from somebody who was basically destined to be unsuccessful. It gave me a job at Denver Water.
That's right, a job at Denver Water.
So Carlos has a certificate in water quality management. That opened up the door for him to get an entry position at Denver Water, which leads to so many possibilities for his future while still pursuing college and now also having a diploma.
Without the opportunity that Emily Griffith has given me, I would probably be a dropout or still working towards my high school diploma with no job or knowing what I want to do in the future.
And now,
my future to me looks bright because of the opportunities that I got here at Emily Griffith, because I chose to learn and choose the right paths that this school put in front of me.
Okay, well, welcome to the new 2016-17 Science Lab. We're just doing it right here in the studio. Okay, guys, so I wanted to keep it kind of fun for our first one, do something that you guys could enjoy, so I wanted to start with food. So actually these food experiments will continue for the next at least 2 more shows, but maybe 3 more shows after this. So today I wanted to talk about cheese making, which is just a cool thing in general, but also some really cool science. So do you guys know what cheese is made from?
Milk.
Milk, yeah. Nice, well done. Do you guys know what is milk?
Protein from a cow.
So it does contain, milk does contain protein, definitely, but it's not just protein. What else is it? Go ahead, Nate, just read it off the screen.
I think it's fat, protein, and lactose.
Yeah, would you call it like an emulsion of fat, protein, and lactose and water?
I think emulsion is what I would call it.
So if we could jump to my computer screen, possibly. I've got a small diagram that just sort of shows this, but milk is actually mostly water. 88% of milk is water. And then in that water are suspended these little particles, proteins, fats, and sugars. The sugar in milk is called lactose, and there's different types of fat and protein. And it's the fat and protein that really allow us to make the cheese. And there's a special kind of protein in milk called casein. Have you guys heard of casein before?
I have.
Cool.
Not really sure what the difference is, but I have heard of it.
So it doesn't really matter too much, but in general, proteins are these really complex molecules. And when we look at them, they're not just straight lines of molecules. They're all twisted and bent up. Becca, could you go to the next slide? When we get a chance, if we could just show this picture of a casein molecule.
That's cool.
They are complex molecules, proteins. Casein is no exception. And the reason that they're so bent up and folded up is that there are special parts of the molecule that are magnetic, positive or negative ends that stick together. And what we want to do is break those magnetic bonds, what are called hydrogen bonds. We want to break them up, break up the casein molecule, which will make it not, so normally casein in milk just kind of bounces around and doesn't attach to other molecules. But as we break those bonds, it'll start to stick to the fat globules, it'll start to stick to other proteins, and it'll make what are called curds, which is the beginning of cheese. So we're gonna break up this casein using acid. But there's different ways to do it. So if you could go to the next slide for me, Becca. Acids and enzymes are the 2 things that curdle milk. So you may have seen bad milk in your fridge before. It might have looked sort of like that pot right there. But really cheese is, in a sense, milk that's been left to gone bad, milk that's been left to get acidic. So we're taking fresh milk and we're just gonna add acid to it to get to this point. Professional cheesemakers, will you go to the next one? Professional cheesemakers use something called rennet. Rennet is the most common chemical used to make cheese. Rennet actually comes from the stomachs of ruminant animals, like cows. It's an enzyme. It's a mixture of different enzymes, but it mainly contains the enzyme chymosin, which does the job of breaking apart that casein molecule like we talked about. But we're going to do it a different way. So if you go to the next slide, Becca, we're going to do it through lemon juice and apple cider vinegar. Okay? So we can jump back to the studio now and we'll actually go through this process. So in making cheese, one of the first things you have to do is you have to heat up the milk. You want to heat it to about 160 to 180 degrees. That will help to kill off any bad bacteria, that might exist, and it'll also help to prep the fat and the protein molecules to be broken apart a little more easily. Okay, so the other cool thing about this is we're going to make half of the cheese with lemon juice, which will give the cheese kind of a lemony flavor, and half of the cheese with apple cider vinegar, which will give just a little bit of that apple cidery flavor. Do you guys have a preference which one you do?
I'll do the apple cider.
Okay, so I'll have you go first with the lemon juice.
All right.
So Nate, into that measuring cup, can you pour? Let's see. Let's just say we can kind of eyeball this. So we need, if we were making a lot of cheese, we would want to measure this specifically. But since we're just making a little bit for demo purposes, we're just going to probably put in roughly a tablespoon of lemon juice. So
Should I put it in here or just throw it in the bowl?
Put it in there and squeeze in more than a tablespoon, what you feel like is comfortably more than a tablespoon.
That looks like more than a tablespoon. There.
Okay, killer. If we need to add more, we'll add more from
Okay.
the Perfect. Okay, so, and I'm also just going to kind of eyeball splitting. I have a pot of whole milk. You typically want to use whole milk for this because it contains the most fat, which is going to help make the best kind of cheese. If you're really worried about fat in your diet, which you shouldn't be, but that's a discussion for another time. If you're worried about fat in your diet, you can use low-fat milk. You cannot use ultra-pasteurized milk. And that's actually the reason I promised Becca we were going to make goat cheese, but you can only get ultra-pasteurized goat milk in the grocery store I go to, so we couldn't make cheese out of it, so I'm afraid we're only making cow's cheese today.
Fine.
But if you can get not ultra-pasteurized goat's cheese, you can make cheese this way with it too. Okay, so, excuse me guys, careful, I got hot milk coming through here. So, this is milk that's been heated again to that range of about 160 to 180 degrees. I'm going to just pour about half of this hot milk directly into this bowl right here. And we're doing this in a glass bowl just so that you guys can see what happens. Normally, I would actually just do this right in the pot that I heated. And all you need to do is when you're done getting it to that temperature range, when you're done getting the milk to that temperature range, you literally can pitch the acid in right then. So Nate, I'll have you pitch the acid in there for me.
All right.
And then here's a stir. You can go ahead and stir that around and tell me what you see happening as you do that. And actually, you know what, Nate? I'll have you add a little bit more lemon juice as you go.
A little more.
That's totally fine. Just kind of have it ready and just squirt more in and stir it.
Until I see something happening?
Until you see something happening?
We move the pitcher, Sam?
Yeah,
so
is it
that
blocking
we
the way?
can- Yeah, so we can see really well what's happening. And the mug, too, if we
the
can.
mug too,
Yeah, it looks like it's starting to
There we
clump up
go.
a little bit.
Yeah,
Oh,
go
that's
ahead. Add a little
weird.
bit more. It's not really too big of a deal if we add a little extra acid.
Okay.
It'll run off.
Yeah, it's definitely starting to clump up a lot more. than what I
Good.
Put in there.
Good. Okay, yeah, go ahead and stir it around even more. Let's add even a little
Okay.
more acid, Nate. And just make sure it's as...
Get it real clumpy.
Yep. So a good ratio if you want to do this at home is you can do a half a cup of acid to... Oh, there we go. That's what I was looking for. Okay, so Nate, is it
pour out
really
your milk
separated
in.
now?
Yeah,
Does it
very
look
separated.
gross, like you shouldn't
Yeah.
drink it anymore?
Definitely.
Now you
I
know you
wouldn't
hit the right
drink that.
point. Okay, so
Yeah, so if you kind of look, it looks like cottage cheese floating in.
floating in water, right? So this is the separation.
Now I don't
this
know
is-
how I
this
feel
is
about milk
cheese
or
having
cheese.
gone.
Yeah.
The milk has gone from milk
Here we go.
to curds and whey. Curds are the chunky parts, and whey is the juice. So Nate,
Kind of
what
see the chunks there that I scooped out. The rest looks like just liquid.
Nate, you can pour that whole thing right into this setup that I have for you here. Go ahead and I'll hold this steady.
Here, we can move it right there.
You want to move it in front
And
so
then
we
we
can see
can
a little bit better?
see
Sure.
it a little bit better.
So what this is just a strainer with cheesecloth on the top. Cheesecloth is exactly what it sounds like. It's cloth for making cheese. And it's made to help strain out the cheese, or the curds rather, from the whey.
I always
So all
thought
this
the
liquid
cloth was
that's come down
made
below-
of cheese.
All this liquid is whey. Whey is the water that was in the milk. It's also some of the protein and lactose and fats. But
So-
go ahead.
Just a side question.
Please.
Like, I sometimes have whey protein.
Yeah, whey
a
protein
meal
comes from
supplement.
this.
Okay.
It dehydrated this. It used to be that whey was a waste product in cheese making, but people would dump it in large quantities, cheesemakers would, and it would have bad environmental impacts. So people started to research what can you use whey for, and it turned out there were so many uses, one of which is protein supplements. So at this point in cheese making, typically what you'll do is you'll take your cheesecloth and kind of just go like this, and you can sort of squeeze the cheese in there to help get some of the whey out. And then you would literally just leave this to sit 20 minutes, an hour. The longer you wait, the less liquidy it'll be. If you want it more like cottage cheese, you can wait less time. If you want it to end up more like queso fresco, like sort of the crumbly cheese they put on top of tacos, you could wait an hour or 3 hours. Okay? All right. Becca, you ready to do the other one?
Yeah.
Okay, killer. So go ahead and put that bowl back in the center for me. Becca, if you want to pour a little in that Tupperware container, I have apple cider vinegar. Okay, so the, perfect. So the,
Do little musical chairs here.
yep, just shuffling around.
All right. Are we all good?
The acidity of lemon juice is slightly higher. It's more acidic than apple cider vinegar. We're going to need just a little bit more. So Becca, if you want to pour 1/3 of a cup of apple cider vinegar into the measuring cup. Meanwhile, I'm going to pour the rest of the hot milk into this guy for Becca.
All right.
And Becca, you may not have to use all that, so what I'm going to have you do is just stir as you're pouring, and when it gets to that point where Nate's was, when it really separates, you can stop.
Okay.
Yeah, perfect. Again, there's lots of different chemicals that can have the effect here. Anything acidic will do this, and then lots of different enzymes will do it too. Once again, the chemical that most cheesemakers use is called rennet. There we go, that's looking perfect. And it's amazing how quick this happens too. There are different kinds of acids that take different amounts of time, but vinegar works really quickly.
I don't even need the rest of it.
You do not. You can put that on the side. Okay, great. So we're going to do the same thing with yours as we do with Nate's, and I'm going to kind of just have them. Actually, Tirza, can you take that? Or actually, one of you guys.
So
Let's put it on the plate there.
Like you can't possibly put too much in, right? Because you're just using that as like to activate the process.
Exactly. The only reason that you would really not want to use too much acid is if you were planning on saving the whey and using it for something else. So folks who make this at home might use the whey for salad dressing. You can use it for meat tenderizing. It's a great meat tenderizer. So for if you're going to do a marinade of some kind, it's fantastic. If you can get unpasteurized milk, which is a whole thing that we can talk about some other time, but unpasteurized milk contains live enzymes and live bacteria. And if you make whey from that, that stuff is a potent fermenter. So you can use it to make kimchi and sauerkraut and all kinds of other cool stuff. Okay. So, all right, so I've just got another piece of cheesecloth here that I'm just slowly unfolding. I'm going to put it back in our strainer and have Becca pour all that liquid right into the cheesecloth and strainer. Nice. Excellently done.
All right.
Cool. All right, so Becca, I'll actually let you, if you want to sort of tie that guy up and squeeze out some of the juice there. So that really is the basic process of making cheese.
I've never done this before.
Isn't it cool and easy?
It's really easy.
I'm just
So-
getting dizzy again.
So next steps for making cheese, if you were making real cheese and you wanted to make that, so really almost any kind of cheese can be made from this starting process. But when you think about other types of cheese that are harder than this or that have interesting flavors, those are cheeses that have been left to age, or we call it in cheese making, we call it ripening. So that was basically the process. Does that make sense? Mm-hmm. So the next step would be we could press it and we could leave it for much longer to let all the water drain off. Okay? And I did that this morning, or really last night. So I made 2 different kinds of cheese here. So again, we've got our lemon cheese and our apple cider vinegar cheese. One cool thing about using these acids that are flavored is that you get a little bit of that flavor in the cheese. So I've got a couple knives. I've got some generic wheat crackers right there. If you guys would each do me a favor and give this a try. This is exactly the same as the cheese you just made. It's just that I made it at home earlier.
Yeah, let's get that picture out of the way so everybody can see this.
Oh, yep. Perfect.
Space over here.
Make everyone jealous of our cheese.
And wait, did you make this cheese?
I made this cheese last night. And you can see the texture. It's probably hard for viewers at home to see, but you can actually see the texture of the cheesecloth on the cheese, which I think is kind of cool. I think it looks nice. This cheese would crumble really well. Oh, and guys, one other thing, I didn't put any salt in this cheese, which lots of people do.
Okay.
Because that brings out a little bit of the flavor.
The salt does?
Mm-hmm. So it'll be a little bit bland, but hopefully you can taste some of the acid that I used to form it.
Thank you.
All right, so this is the lemon juice one. So Tirza, tell me if you can taste any of that lemon juice acid in the cheese. It should be a very light flavor if it's there at all.
There you go.
You can kind of tell?
Yeah, like it's a little lemony.
Just a little lemony, right?
Not like too strong. You're like,
And I think that the nice thing about it is it isn't too strong, but some people like that lemony flavor.
Want some?
I mean, I'll have it in a minute. Yeah, thank you. I love cheese.
this is really cool.
It's pretty cool, right? And so if you want to make a cheese that doesn't have any kind of a flavor, you're thinking, hey, I don't want that apple cider flavor, I don't want that lemon flavor, pure white vinegar, distilled vinegar, will make a very clean tasting cheese.
Now with the acidic acid or like the citric acid that you use, like the lemon juice or the apple cider vinegar, could you also use the powdered citric acid?
I'm so glad you asked that question.
Oh.
Yes, you can definitely get powdered citric acid, and in fact, you can use pretty much any kind of an acid. I did a little bit of research today, so I think that where you want to be is at about 3.5, a pH of 3.5 or below. So on the pH scale, Nate, would you jump forward a couple slides for me here? 1, 2, one more. Okay, so if we could jump to my computer screen, here's the pH scale, and then here's some examples of different chemicals, or sorry, foods, drinks, that have low pHs. So you could use lime juice for this. You could use grapefruit juice. You could use orange juice. And this sounds really weird, but you could use Coca-Cola because of its pH. I don't know what that would do. There's a lot of other chemicals in Coke that might make it kind of weird. But I'm really tempted now to try to make Coca-Cola cheese.
I really think we should try it.
If there's any viewers at home that want to get creative with this, it is a pretty easy process. If you want to do this at home, the only thing I'd recommend is you really need to be careful with heating up the milk. That should be something that's done under the supervision of an adult. But additionally, even when you are, we can put mine right there. When you are heating up milk, you've really got to be vigilant to be stirring it because it can burn easily. And if you burn the milk, you're going to impart burned flavors into your cheese.
Mm-hmm.
So,
would you recommend having a temperature, a thermometer?
Yes, I would. So I didn't have it here to show you, but normally I do this with a pot thermometer, so a thermometer that will hang on the side of my pot and give me a real-time reading. If you wanted to make cheese seriously, and I was watching all kinds of videos on making Colby cheese and mozzarella, because I think I'm going to actually do this now that I know a little bit more about it. It gets more complicated, and you need to be at a specific temperature range for certain kinds of cheese. So you would definitely want that if you got more into this. If you just want to play with it and have fun, just heat some milk up and put some acid in it. Seriously.
So, and it's great.
Right?
It really is.
I've heard that like all cheese is white, or at least most cheese is white. So like when you get cheddar cheese, everybody's used to like orange or yellow color.
Correct.
Is that true of all cheese? Because I heard that they add the color to make people feel more comfortable, like that's what they're used to seeing.
Yeah, and I actually, there's a specific story behind the yellowing of cheddar cheese, and I'm blanking on what it is right now, but that's true. It's a dye that makes cheddar cheese yellow. But you can think of some cheeses that are colorful, like blue cheese, which has sort of a greenish, bluish hue to it, and that's a byproduct of the organisms that age the cheese. So if we were to take this queso fresco, we could put it in a room that was clean and at a steady temperature, it would age over time. Bacteria in the air, just like they ferment other things, would ferment the cheese, changing its flavor and changing its color a little bit. But in its initial form, all cheese is white. Assuming the milk you use is white. I guess.
Hopefully that's the case.
And this is giving me all kinds of ideas. We could take milk, we could dye it purple, and I bet if we made cheese from purple milk, you would get purple cheese.
We should try that too.
I don't know. Maybe it would run off in the way.
and purple cheese. Those
Somebody
are two things I'd like to do.
I wonder if you used a different flavor milk.
Or do like chocolate milk cheese? Is that what you're talking about? Now we're getting really crazy. If anybody at home wants to try something like this, make it, post a picture or a video on our Facebook or our Twitter. That would be amazing. Or maybe in a few weeks, we'll try it ourselves. We'll see.
All right.
Awesome.
Cool. Any last minute questions, guys?
That was awesome.
Cool. Well, hopefully you enjoyed making cheese with us. We're going to take a break, and we'll be back in the studio in a few. Thanks so much.
I was missing something in my life.
With a lot of passion for
one's
filmmaking
good,
and editing.
So I went to emilygriffith.edu, where I went to go check out their video production and editing program.
Emily Griffith Technical College is affordable and located downtown.
Yes, we got here.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. never mind from when, why, or how.
Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Welcome back. I'm just finishing eating some of this wonderful cheese. But if you're just joining us or just joined us during our experiment, we'd like to give you our contact information so that you can call us with your homework questions. So you can get a hold of us all of these different ways. Phone number 720-424-1666. Social media at EG Homework. Facebook really is probably the easiest way. But then you can also text us at the number on your screen and email us at homework@emilygriffith.edu. So all of those work to contact us. Oh, also to get an answer to the trivia question. We've had 2 guesses so far today, so third time's the charm. I know it.
And speaking of the trivia question, Tori, can you just remind the audience, if they haven't heard, what the trivia question is today?
Okay, the trivia question is, where would you find the world's most ancient forest?
Not New York or Germany.
Right.
Right.
You can eliminate those 2.
I liked both of those answers, though.
Yeah.
They really were.
There is something about the Black Forest about its age being old, but it's just not good enough.
Not quite.
Not old enough.
So we have time for one more question, looks like, from social media. It should be a quick one.
Okay.
Okay.
So what do we
This
I'll
one
take
is
any of those.
From Jonathan, and he says, what's the difference between a linear equation and a nonlinear equation?
Okay, I got it. A linear equation, what makes an equation linear, first off, is the shape that it creates when we graph it. For example, a linear equation is going to almost always, or not almost always, it's going to always, not almost, always create a line, no matter what. When we're writing a linear equation, and I'm going to give an example of it, what makes it linear is the degree of the equation. And the way that we talk about the degree is by the highest power that is on our variable. And what you can kind of see here is that there's no power written on there, so really it's a first degree equation, and that's what makes it linear. Anything else that is not first degree would not be a linear equation. For example, if I had something like this, 3x squared plus 2, that would be a nonlinear equation. So definition of linear is, first off, that it creates a line when you graph it, and then second, that it's a first degree equation rather than a second degree or something like that. I think that answers it. I think it covers it.
Straight up.
Yeah, and I think the interesting thing about that is like thinking about what happens like when we have a linear equation, changes by the same amount every time. Mm-hmm. Whereas like nonlinear, typically it's changing because your value before is changing.
You're right. That's a completely defined characteristic of linear equations, is the fact that there is constant growth.
Right.
Yep.
Right.
All right. I guess we're going to get our answer to our trivia question. We didn't have a winner, but hopefully you guys are watching if you guessed and didn't get it. So Tori, tell us, what is the trivia question and the answer one more time?
The trivia question is, where would you find the world's most ancient forest? And the answer to that is the Daintree Forest north of Cairns, Australia, if I'm saying that correctly.
I've not ever even heard of that forest.
Right. No kidding. Right?
But it's quite old.
I didn't know. Yeah, I didn't know. What do you know about it? I want to know more.
What do I know? Well, first of all, I know it's the oldest continuously living forest. That's why we're talking about it, obviously. It's thought to be 165 million years old, which just seems like a crazy amount of time.
165?
165 million. And it's got a pretty rich diversity of plants, animals, and other things. It's got at least 663 species of vertebrate animals, 230 butterfly species, 135 dung beetle species. I didn't even know there were that many different types of dung beetles. And 222 species of land snails. So pretty diverse in like species that I didn't even know had that many different varieties.
Yeah, I didn't even know that there were that many. I'm trying to look up right now how old the Black Forest was. The Black Forest is.
Yeah, you know,
I'm almost there. I'll tell you in 1 second.
So one of the things that I was thinking about was, as we think about what could be the oldest, so you think about the supercontinent Pangaea, which would have existed around 300 million years ago, and the splitting of that continent. A lot of land that used to exist on the Earth, in fact, all the land that used to exist on the Earth, if you go back far enough, is no longer here. All continental land eventually gets destroyed and reborn as new continental land through subduction zones, mountain building, volcanoes. This takes hundreds of millions of years, but it happens. And so the fact that you even have any land around that is 165 million years old is kind of incredible. And then the fact that a forest has lived there continuously. So Australia is very famous for being an arid rock of a continent. It's a desert, and most of it is. But then it has these little pockets, and if I'm not mistaken, Australia was covered in forest at one point, and that over time it's dried out, and it sort of left these little pockets of this gigantic rainforest that used to exist, which again are a continuously living thing, 165 million years. Not to say that any of the plants there are that old. And in fact, when I first heard this question, and I think Becca said it, Becca said, isn't it California, right? Didn't you say?
That was my guess, was the redwood forest, was my guess.
So I know that the bristlecone pine forests of California have trees that are 4,000 years old, individual trees that are 4,000 years old, and I thought those were the oldest living organisms on the planet, period. Anything living, was my understanding.
And they're not.
So that's where my mind went, but I guess this is like a forest is an ecosystem that's just, you know, plants, trees have died and been born again, but the forest itself is that old.
I'm not finding much about the Black Forest other than that it's been around for a very long time, since medieval times, as far as I found so far.
Which would be like 1,000 years.
Sorry, my research on the spot is not all that great.
No, it's actually hard to find. I was looking for it too, and I keep finding Black Forest Age of Empires.
Yeah, it just wants to talk about it, not tell us how old it is. This
Yeah.
is our issue. It's not easy to find, I guess.
Yeah,
the age of a forest.
Speaking of like the really old plants, like the really old like redwoods and such, one of the things that's interesting that I read was that there was a plant that was rediscovered in 1971, thought to have gone extinct, but it's called the Idiospermum australiensis something, but it's known as the idiot fruit, and it's actually thought to have been around when dinosaurs roamed the earth. So it's kind of again like a crazy amount of time for a plant to be
around. Right? It's true, to stay here. Yes.
Yeah. Right,
live through extinctions and.
Right, that's the incredible thing, right? Is that really it's that life has been here for, you know, we think that we know life going back 3 billion years in a simple form, but usually it dies off and we get new types of life.
Cycle through.
Very interesting. All right, well, we're done for this week, so we have to say goodbye, but we'll be back next week every Tuesday and Wednesday from 4:30 to 5:30. So save your homework questions, send them in on Facebook, and we'll see you then. Oh, also, don't forget that we're live on Facebook, so you can watch us live and the show today. You can watch again. See you then.